what we're going to talk about now in this session, and Jay's alluded to it a couple of times, is playing with text and text data in Domo. I was actually trying to think of a really catchy like hook thing to get anybody in. And so I totally made up a statistic that like 99% of all the information that's ever been conveyed has been through words, which sounds about right. If you think about all the literature and history and everything else that's gone on, it's mostly words. There's tons of data that's out there that's represented in text. And it can be difficult to pull that and to get some usable insights out of it. But that's what we're going to talk about today. And I hope that over the course of this, I'm going to show you some code. Hopefully I'm not going to make it scary because I know code is scary for some people, but we're going to actually walk through some really simple ways that you can start getting value out of all this textual data that exists. So I'm excited and this will be fun. So I will share my screen and there we go. Started building out a little dashboard, but what we're going to do for this is run into the Jupyter workspaces. And the reason why is because while SQL is fantastic and so is Magic at a lot of things, text data is not one of those things that it is phenomenal at. There are better tools for the job. And for Domo, specifically, R is probably one of the best tools that you can use. And I'm sure Grant is now cringing because I talked about R and I'm not doing this in Python. I don't know, Jay, if you're going to cringe as well, but it's in R. And there's a couple of reasons for this. One, R is a fantastic language. Both of them are. But when you're working inside of Domo with the data science tools, sometimes you run up against memory limitations where the amount of data that you can actually have and process is limited. And R is a little bit more efficient, especially when it comes to text data. So that's what we're doing here, is using R. So this is a notebook. And if you're not familiar with a notebook, it's a way to intersperse text with code and then outputs of code. And so I've done a handful of things here already. I've brought in a whole bunch of packages. And these are wonderful add-ins that you can pull in to do specific functions. And this is why Python and R are better tools for text data and this process, because so many people have done the heavy lifting of making tools to make it as easy as possible. So I've loaded these up in the instance, and because it's Domo, we can just grab some data from within the Domo instance already. And Jay gave this to me about a week and a half ago. And this is Domo Dojo data. So we've got here, as we read in the data, a couple of columns. We've got the URL about the discussion. We've got the categories that they've been tagged with, the title, this gobbledygook, which is actually what we're going to be using, which is the body of the text. You can see there's a lot of HTML in here. We've got the author and we've got a created date. So this is our data that we can work with. And really it's this body that we want to be able to parse. And one of the first things, the first time I did this sort of work, not actually, I take that back. It's not one of the first times. One of our customers, when I was working at Domo, wanted to look at their text data because they had a mental idea, a model in their head that certain words, when they heard them, indicated that projects were going to go over time or over budget. And they wanted to see if they could figure that out. Was that real? Was that not? Going back to Andrew's point on the hypothesis, they had an idea, they had a hypothesis, and they wanted to test it. And this is one of the simplest and easiest things that we can do with text, is we can count them and do some proportions. To do this, though, we need to change the data structure a little bit. And this is why text data is so hard, is we've got these sentences, there's meaning encapsulated in all sorts of things. We need to break it apart. We need to break it down. And what we really want is some tidy data where we have one row per word per document or per post in this instance. And so by running the tidy text function, we've got this wonderful thing called unnest tokens. And when I run this code, I get the same URL multiple times, but I've now broken up the words so that every word is its own row. And when I write that out to Domo, all of a sudden I have a ton of power where I can leverage Domo's own platform to start to analyze this. So I've just written out this to a thing called process reviews. And if I come, oops, let's go over to my dashboard. I now have counts of my words. So here's all my words. Here's how often they occur. This is only the top 100 words that exist and some of the categories that they're running through. I also created a word cloud because it's hard to do text analysis without a word cloud. They just look pretty even if they're not useful. But you'll notice a lot of these don't actually mean a whole lot. We've got a, in, chart, bar, and. A lot of these words aren't very useful. And so we need to go back. And this is part of the data science process. It's a lot of iteration. So if we go back in here, one of the things that we can do, and again, people have made a nice library for to make it easier for us, is we want to remove what are called stop words, the, and, but, things where the words themselves are not adding a lot of value. And here we can take, again, the same data, we'll still unnest tokens and just add one little piece, which is an anti-join, where we're getting the stop words. So someone's created a list of all these words and we can just get rid of them. An anti-join is actually what it sounds like. It's show me everything in one data set that is not in existence in the other. So by running this little bit of code and then writing this back out to Domo, I can go back to my data set and refresh. And we should now have gotten rid of all of those stop words. Now we have a whole bunch of words that make a whole lot more sense. As expected, Domo is the top word. That's it more than anything else, followed by card, charts, and we can just count them. And we have those proportions. This chart is what I used for my customer, essentially, where we just looked and said, okay, based on every word that exists in your text, in your document, your data set full of text, 30% are on time and 70% are not on time. And so we were able to confirm their intuition that they had just by counting up the words. And the nice thing was we actually had some instances where we were catching words through these charts that they had not considered. They hadn't caught those, like, oh, yes, that word, but that makes sense. And they were able to, within a month, they had started changing their processes and made their business more efficient, which is fantastic. So really simple things, sums and averages, which make up all of data science, used in a creative way can start to help help the business make decisions better and really provide value. So that's our first little bit, word counts by category. And then over here, we can kind of see in our word cloud how often or in how many different categories these words occur. Domo is occurring in 40 different categories, group in 28. And so we can kind of look at the balance between these. How often are certain words used in certain categories? Going back to the code, we're going to go to the next big thing, which is sentiment. And this is usually what people think of. I don't know if you're thinking about it, but this is what I usually think about when people talk about using text for analytics, is figuring out what is the value? What are people being positive or negative about these things? And this is one of the projects I worked on for Domo itself. When I worked there, is we had our NPS data, our Net Promoter Score. So how likely are people to like your products? You probably had to fill out a couple of those surveys, or hopefully you filled it out and didn't just click ignore. But we took all that data and we needed to figure out, are people happy or not, and about what part of the instance, what aspects of the product were good or bad, or were people talking about positively or negatively. And the simplest way to do this is, again, to just join in another library that someone has built that defines each word as positive or negative. And that's what this get sentiments does. We're going to use a library by a guy named Bing, and we're just going to join that into the data that we've already developed. It's already in a nice tidy format, so this join makes perfect sense. It has the words, it matches on the words, and we'll bring it out. We can look at the first couple of rows here, and it's the same data except now we have a new column for sentiment, and we can see that some are positive. So the word useful, that's positive. And a lot of these are not applicable. They're kind of neutral words, methodologies and solution. They're not really positive or negative, which is great. They don't have a value then. And so we again can jump back to the dashboard and refresh. And we now should have cards where we can look at the sentiment over time. And we can see for the comments in the dojo, are they trending more positively or negatively? What's the amount? All of that in this card right here. So it looks like there's a downward trend in general. There are just not as many comments being posted in the dojo anymore that have any positive or negative values. But for the most part, the values, the topics, the words that are being used are more positive. And here we can come down and actually look at, again, proportions to say if the topic is card building, is it more positive or negative? And it looks like it's slightly more negative. Idea exchange, definitely more positive. It's fantastic, very positive place there. Best of the month, very positive. So we can start looking and seeing, okay, where are our different, where do we want to focus on? What are the things that people are talking happily about the product? What are they not? And how is that changing over time? Or again, using Domo, can we just look at things that have been tagged with data flows and look at their positive negative correlation? So for data flows, there was a lot of negativity coming in around 2018. And if we look into here, here's a table that I created, which shows the dates, the categories. These are all data flows, so it's filtering properly. And then we can start looking at the actual comments and seeing what's going on. Hoping it can be done in a beast mode. So it looks like a lot of people were trying to do things in beast modes or in data flows, and it wasn't working properly. And so that can give some indication, Adam, of things that you may want to focus on, things that would be helpful from the community. And again, these charts were really, really easy to make as soon as the data was in the right structure. We go over to ideas exchange and see how that's trended over time, far more positive. And so here's sentiment analysis. And one of the things that we will do, and Jay, I'm not sure how you want to handle this, but this notebook and all of its code, I'll be sharing with everybody who would like it. And so you can load this up into the dojo, you can analyze data. I've actually got another data set of product reviews that you can run through this exact same exercise by swapping out the data sets. And if I'm really ambitious, I'll rewrite it in Python as well for Grant. But this is what we have. We have now sentiment, we have tidy data where we can analyze it, we can join in any other information that we'd like to. And then we can move on to the really fun part, which is modeling. And the modeling aspects are a little bit different because when you're doing modeling, there's two main types of machine learning, which I refer to as modeling, because we're taking the mental models that we have, and then we're trying to get the computer, hopefully, to validate those or invalidate those hypotheses by using algorithms to find patterns. And there's two major aspects, or there's a demarcation line between the types of models that you can run. The first is called unsupervised models. And unsupervised models are where you don't actually know what the answer is that you're looking for. You just say, go find a pattern. And that's what we're going to do next, is we're just going to go find a pattern, thinking that maybe there's something hidden in this data that we can't quite see yet. And these models can be really powerful. They can find clusters that you may not be able to see because there's so many variables they can look at. In this case, we're going to have a variable per word. And so it's huge. And we'll see if we can find some topics that are there. The problem with unsupervised models is that they need interpretation. You can't just leave them because it's going to find a pattern no matter what happens. So last couple things, modeling. We're going to add some new libraries. And we're going to change the data structure a little bit more. So instead of having one word per row, which we've had for the tidy data, which has enabled all of the other cards and works well inside of Domo, we're now going to change things and flip it to one row per document and one column per word. And this now then is considered a matrix where we can actually do math. And we can run some of these more advanced algorithms to find our topics. Specifically, we're going to run an LDA, which is a latent district algorithm, I think that if I remember correctly. And we're going to look for 10 different clusters. That's what our K is. Transform that back into a data set that we can actually use. And if we look at our topics, just the top 15 rows, what we'll see is a column, new column for topic, 1 through 9-ish. I actually put a limit on here, so not all 10. But most of those words, or most of those topics for each word, and then a score, meaning how relevant is it to that topic. So it's just gone and found patterns and thrown every word into the probability that it would be in this kind of pattern. And we can write that back out to a data set as well. Come back in here, and here are my topics. And it's beautiful, it's pretty. It means nothing at the moment. It means that we found 10 patterns, or the computer did. Those patterns may or not actually match to anything at all. So if we look at these, we can see Domo comes across the vast majority of all of these, as does data, cards, data sets, charts. A lot of these show up everywhere. Now this is an interesting one because it's only showing up in 2 different places. So these 2 may have something more to do with users and groups. It also could be dealing with grouping. So we're not quite sure. Lines, that's probably a line chart. So those may be, these topics may have more to do with lines. But this is one of the benefits and the necessary evils of unsupervised models is you then have to come back and interpret them. Now, iterating over these and figuring this out can be really helpful. And I worked with a person who actually analyzed all of Domo's user data and found, using an algorithm very similar to this, found 6 distinct groups of people. And we all, I think, probably would fit in one of those groups where we're mainly the admins. They said there's a certain subgroup of people who use the admin console more than anybody else. They also often do data flows and they're building cards, but there are another group of users who only look at cards and pages. There's another group of users who only build cards. There's another group of users who only use data flows and connectors. And by using these unsupervised models and using a bit of knowledge and thought, we're able to actually figure out here are these different clusters and here's the usage patterns around them. Now, if we spent some time on this, we could probably figure out what each of these different groups means. What is it representing? Whereas if we just look at it real quick, it doesn't mean a lot. This one does actually mean something. It means I can't understand it because it is in non-English terms. So this is the Japanese one. So one solid topic that we've figured out there. The next thing that we can do, or in theory could do, is run a supervised model. And supervised models are really, this is where you really get the value. Because in supervised models, we're actually taking data where we have data where we know what the answer is. So instead of just saying, go find a pattern, we're like, find a pattern that gives me this sort of answer the most amount of time. And using a random forest model, we can take a whole bunch of the words and see how well they map to different categories. By just looking at the words themselves, can we map them to a specific category? Are they useful enough? And honestly, this hasn't quite worked yet, so we'll see if it works. But this same idea is something I did for another one of our customers, and we also utilized the Amazon's SageMaker integration with AutoML inside of Domo, where we took all of their data. They were an auto parts manufacturer, and they had all of these comments about things that weren't working. And for their particular business, it was awful because they had engineers who were highly qualified, highly skilled, who had to go read through every single one of those comments and then figure out what it was actually talking about, what part was really the problem. And it took a tremendous toll on their time. It was a necessary but not particularly liked aspect of their job. And by using these tools, changing the data structure a little bit, and then putting it in AutoML, where it found the best fitting algorithm, it actually was predicting with a very high degree of success for most parts what those parts were without even having the part name. And it was saving them huge amounts of time and then huge cost savings as well. So using supervised models it's far easier to find specific business value by automating tasks that we can do. Similar to what John showed, where he was able to classify his groups of people into different risk categories and profiles, which is something we did a lot inside of as part of the data science team. This, I think, is going to run for a while, which is too bad. But the idea there is that we can actually predict what's going to happen and then take more action off of this. So that is a incredibly quick whirlwind tour of some really basic things that we can do with natural language processing and text analysis inside of Domo. Are there any questions? What do we have?
Yeah, John. So one of the questions that came in while you were talking was whether or not Jupyter Workspaces was a premium feature.
So yes, the Jupyter Workspaces, along with AutoML and the scripting tiles inside of Domo, the data science tiles, is all part of the data science suite. It is a premium feature. It's a really valuable thing. Jupyter Workspaces can be really, really valuable because you can explore data, you can iterate through it very quickly, you can pull in stuff from outside. And if you are concerned about having a secure environment where all of that happens, it is perfect because it's within Domo's VPN, it can be accessed anywhere, it's fantastic. If you are not, if those are not huge concerns and you are very cost conscious, you can also run these Jupyter notebooks on your local machine or another system.
Yeah, John, we did
can be helpful.
We did the whole talk. We did the whole video about it. I'll make sure to include a link. What I want to do real quick, guys, is share my screen for half a moment and kind of put a bow on some of the things that, John, you were saying. Oh, wait, one more question just came in. Does the Jupyter Notebook? Anonymous attendee is asking if Jupyter Workspaces comes with the data science suite or is that separate? Instead of John and me getting into that answer, Ben Ainskoff tomorrow is I want to say he's a product manager over the entire data science suite. He's going to be talking at length about that product offering, similarly to how Dan Hendrickson was. So that would be a great time to get a little bit more clarity on how Domo sells it. My gut check response says no. Domo Jupyter Workspaces may be a separate cell from the Magic ETL scripting tiles, and the scripting tiles may be a separate cell from the automated scripting tiles. So I would actually say check with your AE and or come to the session that Ben's delivering. I have to check the schedule. I honestly don't remember exactly which day. One thing I wanted to talk about for a moment is I have put together a YouTube playlist of stuff relevant to the ideas exchange. And one of the videos I came across was this guy talking about how to think like a programmer. It's interesting because what he says is he differentiates between the algorithm and the code. And he describes the algorithm as the set of steps that we take, usually articulated in plain English, to get to the solution or the thing that you're trying to build. And again, I think that aligns with what Andrew and Brett were talking about, taking a business problem, turning it into a data problem, and then building a solution once you know what the problem is. Part of my inspiration for this talk, I'm not going to lie, John, is a user asked me, Jay, how do I analyze emails? I was like, I don't know. but I'm organizing a conference. I'm gonna have John explain it. Now, what John did for us is he walked through how to tokenize, how to split, a chunk of text into individual words. He talked about stop words. He talked about sentiment analysis. And some of you guys are thinking, well, how do I apply this? Well, I encourage you the next time you're thinking, I want to do advanced analytics, say, well, what's the problem that you're trying to solve? And then if I handed you the solution, how would you know if it was good or bad? Like if I handed you the cards that John was showing us, would you be excited by those cards? Or would you say, oh, I need this next bit of iteration in order to be satisfied? I guess the point is to do that process first. State your business problem, kind of go through what Andrew was talking about with his, Andrew, what was your app called? Idea app? Step through those steps of how do I validate that this thing is useful? And then once you get to the end of that, then you hire someone like John, who did you say that you were a doctorate or a PhD?
No.
Oh, doc is a doc. And then you hire someone to build it for you. But the first step is to kind of go through this process. So more on that in another session. Are there any other questions that kind of came in related to text analysis? Just checking all of the different places that we're managing conversations.
Yep, and just in case someone's reading the chat, and thanks for putting that. The notebook is already in the Domo dojo, and we will share it there. And anyway, you can actually take that code and swap out the data set that I've put in on the dojo for your data set, and maybe change one or two other things where you're referencing the column, and it will just run. Like everything just works, which is why we want to share it. I feel like learning code is really a very difficult thing a lot of times if you're not familiar with it. And so having a template that you can just play with is really nice and easy way to get started.